Unit 11.3, we're going to be finding the lateral area, total surface area, and volume of pyramids and cones. Now, all these blanks that are to be filled in here, I'm going to leave for you to look to your student edition to study, and I'm just going to talk about those pieces and parts. Again, a point or a corner is called a vertex. More than one would be called vertices. We have 1, 2, 3, 4, 5 vertices in a square pyramid. A segment is called an edge. The edges at the base are called base edges. As you go up with the sides, the edges that make the sides are called lateral edges. Lateral edges. The bottom is called the base. It is a face. It's just a fancy face called the base. The triangles going up are called lateral faces. So any flat surface is called a face. If the face is a top or bottom, it's called a base. If the face is a side, it's called a lateral face. If an edge is at the base, it's called a base edge. If an edge is on a side, it's called a lateral edge. Now, there's something special in a pyramid that we do not have in a prism. We had the height of a prism, which is straight down from top to bottom. The height in a prism was one of the sides of the prism. But in a pyramid, it's from the top straight down to the bottom, perpendicular. And that perpendicular in there, remember the little theorem that says, or the definition, a line perpendicular to a plane. If a line is perpendicular to a plane, then it's perpendicular to all the lines in the plane that pass through the point of intersection. So the height would be perpendicular to every one of those, okay? But we also, when we are dealing with a pyramid, we have triangular sides. And when we're finding area of sides, we're going to be finding the area of those triangles. And the formula for a triangle is 1/2 base times height. The height of that triangle goes down a side. The word for side is lateral, and so we call that thing the lateral height. So that's a new thing for us. The lateral height is the height from the peak down one side, which helps us find the area of the triangular side. Okay? Now, we're going to think about formulas as they relate to prisms. The formula for area of a prism was perimeter of bottom times height. Of prism. And the reason we say height of prism is because there's also a lateral height, right? Now, but the thing is on a prism, if we were to fold it out, a square prism, then we had 4 sides that did this. But if we fold out a square pyramid, we would have that. Each of those triangles is half the area of what the rectangle would have been had it been a prism instead of a pyramid. So the lateral area of a pyramid is half the lateral area of a prism. The lateral area of a prism is perimeter of bottom times height. So it's 1/2 perimeter of bottom times height, but not really, because the height of that rectangle actually was the height of the prism, but the height of each of these triangles is not the height of the prism, the height down one side of the prism. So each of these are not heights, they're lateral heights. And so instead of having height of prism out here like we did for a prism, we're going to have times slant height. Or lateral height. I'm going to go ahead and call it slant height. You can see in the book it's called slant height. It may be also called the lateral height. So lateral height or slant height. Let's see how we got that. So for a prism, it was perimeter of bottom times height of prism. For pyramid, it's perimeter of bottom. See, we still have perimeter of bottom. But instead of height, it's slant height. And we've only got half as much. So it's half perimeter of bottom times slant height. Okay? Now, a prism has a congruent top and bottom. So for total area on a prism, we said 2 times area of bottom times. But a pyramid only has a bottom. It doesn't have a top. So we're just going to have area of bottom for a pyramid instead of 2 times area of the bottom plus the lateral area. Okay? And then volume. Volume is 1/3 of what it would have been had it been a prism. The formula for volume of a prism is area of bottom. You fill up the bottom. Times the height of the prism. This is not slant height here. This is height of prism. So the volume of a prism is area of bottom times height of prism. If it's a pyramid, it's 1/3 of what it would have been had it been a prism. So it's 1/3 area of the bottom times height of prism. Let me show you here if I can do a decent drawing of a square prism, which would be a cube. If I were to draw a pyramid in here, then the volume of that pyramid would be 1/3 of the volume of that whole cube. It only takes up 1/3 of that space, okay? So there's our formulas. We study them, we memorize them, we try to understand them, and then we apply them. What we have here is a circular pyramid, which is called a cone. It's a circular pyramid. To find the lateral area, we take 1/2 of the perimeter of the bottom times the slant height. The slant height is 13. We just need perimeter of the bottom. The bottom is a circle. Perimeter's distance around. Distance around a circle is called circumference, and circumference is 2 times pi times the radius, which is 5. So we have 1/2 perimeter of bottom, in this case circumference, times slant height. Okay? I'm going to take out those letters there so we can just work our way down the page. So this is all multiplication. Half of 2 is 1, times 5 is 5, times 13 is 65, times 3.14. So I'm going to go to the calculator and do the rest. 65 times 3.14. 204.1. And so the lateral area is 204.1. I'll write that a little bit better. Okay. The total area, notice there's not a top and bottom. So if we want the total area, we're just going to add the area of the bottom to the sides. The bottom is a circle. Area of a circle is pi times the radius square. And the radius was 5. So that's the area of the bottom, and then we add the lateral area of 204.1 to that. So we're going to go 5 squared is 25. 25 times pi is 78.5. Maybe I'll double check that. I'm not trusting myself. 25 times pi. Good. Which is 78.5 plus 204.1. And so the total area would be 282.6. So there's our lateral area. There's our total area. Volume. Volume is 1/3 of what it would have been had it been a prism. So it's 1/3 of the area of the bottom. The bottom is a circle, which is pi times the radius, 5 square, times the height of the prism. Because it's like we're filling it up, and we fill it straight up, see? We're going area of bottom times height of prism 12. But it's not a prism, it's a pyramid. So it's 1/3 of what it would have been had it been a prism, see? So there's where the third came in. So 1/3 of 12 is 4. 4 times 5 squared. 5 squared is 25. Times the 4 is 100. 100 times 3.14 is 314 for volume. Okay? Any questions so far? Okay? Here we have a regular hexagonal pyramid. Now things are getting a little bit more complex because we've got all of our regular polygon stuff in the middle of all of our lateral area, total area, and volume stuff. So let's just take off. The lateral area is 1/2 the perimeter of the bottom times the slant height. It's giving us a slant height of 20.88. That's the slant height or lateral height. So we want perimeter of bottom. The bottom is a hexagon. It's got 6 sides that are all the same. We just need a side. Now, remember to find the interior angle sum, you take the number of sides minus 2 times 180 divided by the number of sides. I'm going to clean that up. The number of sides minus 2 times 180 degrees divided by the number of sides. So we would have 6 minus 2 times 180 degrees divided by 6. And when we did that, we got an interior angle of 120 degrees for a hexagon. So we have an interior angle of 120 degrees. Now, if we draw the little triangle in the front, where we have half a side, that's this, the apothem, which is that 6, and we could draw a radius to here. Now that would be a triangle. I'm going to draw it in here. That would be here. So it was the apothem here that was 6. I've called that x, and this is radius, and the x is half a side. Each angle of the hexagon was 120. The radius bisects that, so that's 60. So we have a 30, 60, 90 triangle. The x is the short leg. Long leg is equal to short leg times the square root of 3. So long leg 6 equals short leg x times square root 3. We undo multiplication by division. And so we get x equals 6 divide square root 3. We have to rationalize the denominator. So we get 6 square root 3 over 3. Which is going to be 2 square root 3. And so x, which is half a side, is 2 square root 3. That means a whole side is double that, 4 square root 3. And so we have a side. And I'm going to mark that in here, that a side is 4 square root 3. So now we can find the lateral area. Half of 6 is 3 times 4 times 20.88. So half of 6 is 3. 3 times 4 is 12. 12 times 20.88 is 250.56 square root 3. $250.56 square root 3, which I probably should change to a decimal. Let's just go ahead and do that and round it and take the square root of 3 off since it's got a decimal there. So we'll just go times square root 3. And that would be 433.98 if you actually multiply it like that, which is not matching my teacher's edition, which is why I'm hawing around here. Okay. So let me bring it back and pause it and see. So I had messed up in my teacher's edition, so we're going to keep what we got here. If we change that, we're going to have 433.98. I've made a note to fix that in my teacher's edition. I apologize for the mistakes again. Okay. And so the total area, a pyramid only has one base or one bottom. So it's going to be the area of the bottom plus the lateral area. Now the bottom is a regular polygon. So we're going to go 1/2 the apothem 6 times the perimeter, which was 6 sides at 4 square roots of 3 apiece. So 6 4s are 24 square root 3 for perimeter. So we have area of bottom 1/2 base 1/2 apothem times perimeter plus the sides, which is 433.98. So we have the area of the bottom plus the sides. So 1/2 of 6 is 3. 3 times 24. Square roots of 3. We'll just go ahead and do all of that. So we're going to have 1/2 of 6 is 3. 3 times 24 is 72. 72 square roots of 3. So 433.98 plus 72 square roots of 3. We're going to take it as a decimal. 558.69. 558.69 for total area. Okay. Volume. Find the volume. It's 1/3 of what it would have been had it been a prism. Had it been a prism, it would have been the area of the bottom, which is 1/2 times apothem 6 times perimeter 24 square roots of 3 again. But it's times the height of the prism or the height of the pyramid rather than the slant height. And it's telling us here, and I'll just erase so you can see it. It's telling us here that the height of the pyramid is 20. So the volume of a pyramid is 1/3 of what it would have been had it been a prism. Had it been a prism, it would have been 1/2 apothem times perimeter, which is the area of the bottom, times the height of the prism, 20. So 1/3 times 1/2 is 1/6. 1/6 of 6 is 1. 1 times 24 is 24. 24 times 20 is 480 square root 3, and we're just going to leave the radical on that one. Okay? Any questions there? That's approximately 720. We can go ahead and check that out if you want the decimal form. 480 square root 3. it's not. It's 831 because I had messed up on the other one, right? So 831.34 if you wanted a decimal value. 831.34. Okay. Any questions on the hexagonal pyramid? All right. The square pyramid. All right, we're going to find all those little pieces. Remember that if the base is a square, then each angle is 90. We know that a radius bisects an interior angle, so half of 90 is 45. So that's 45, and this is 45. So angle 1 is 45 degrees, and angle 2 is 45 degrees. And we want to know x. The whole side is 20. The apothem, which is that dotted line, bisects a side. So if that is x, then that is x. The whole side is 20, so each of those are 10. So x is 10. X is a leg of the 45, 45, 90 triangle. In 45, 45, 90 triangles, the legs are equal, so y is also 10. Z, the radius, is the hypotenuse. In a 45, 45, 90 triangle, hypotenuse is equal to leg times square root 2, so it's going to be 10 square root 2. These formulas should all be in our head, and we just plug it in. Hypotenuse equal leg, which is 10 times square root 2. The height of the prism. Okay, I'm going to draw it in black. The height of the pyramid, excuse me. Whoops, I missed. Let me try again. Sorry. I've got to find something the height is in that I know enough information in to solve for the height. Now, if we go across here and back up, I have a right triangle. I'm going to do c squared equal a squared plus b squared. The c of that is the 26, which is a lateral edge. We're going to let h be the a. The other leg b is the radius, which is 10 square root 2 squared. So we're going to do the 26 squared, which is 676, is equal to the height of the prism square plus. Now we're going to distribute that. 10 squared is 100. The square root of 2 squared, the square cancels the square root, and we get the plain 02. And we have 100 times 2 is 200. Now you may want to study on that a little bit. Okay? So we're going to subtract 200. Subtract 200. We get height squared is equal to 476. Take the square root. And so we have square root 476. If we try to break that down, 476 divided by 2, we would get 238. Divided by 2 is 119. Rewrite it as the product of its primes. Circle pairs for square root. Make a new radical. One from the set pops out. What didn't get circled in a set goes back in. And so we have 2 square root 119 for the height as a radical in simplest form. The lateral height or slant height is that L. I'm trying not to erase too much stuff. I'm going to go ahead and take out the radius. I'm going to take out that. Take out that just so I can see. The slant height is perpendicular here. I'm going to use the triangle formed by the slant height, half a side, and that edge. That gives me two sides, 26 and 10, and I'm looking for the third side slant height. And so I'm going to do a Pythagorean theorem. Let me do a little house cleaning here. So I'm going to use c squared equal a squared plus b squared. The hypotenuse was the 26, so 26 squared equal a, which is 10 squared, plus the lateral height squared, or the slant height. Lateral height, slant height, same thing. We square them. We get 676 is equal to 100 plus L squared. We're going to undo, so we subtract 100. Subtract 100. We're going to have L squared is equal to 576. To get rid of the square, you take the square root, and we get slant height is 24. So the slant height is 24. Okay? So we've got all of those pieces. We needed some of those to be able to find the total area and the lateral area and the volume. So I'm going to clean house again. We've got all of that stuff figured out. Lateral area. Lateral area is 1/2 perimeter of bottom times slant height. Slant height is L, which is 24. Perimeter of bottom, the perimeter of a square is 4 times the length of a side. Each side is 20. So we have 1/2 perimeter of bottom, 4 times 20 times slant height 24. We multiply, half of 4 is 2. 2 times 20 is 40. 4 times 24. Say it again. Half of 4 is 2. 2 times 20 is 40. 40 times 24 is 960. And so the lateral area is 960. Okay? Total area, you add the area of the bottom to that, because a pyramid only has one bottom. It doesn't have a bottom and top, doesn't have a top. So we're going to say area of bottom, which is area of the bottom's a square. Area of a square is side square. So there's the area of the bottom, side square, plus the sides, which was the lateral area of 960. 20 squared is 400. 400 plus 960 is 1360 for the total area. Any questions there? Okay. volume. The volume is 1/3 of what it would have been had it been a prism. The volume of a prism is area of the bottom, which in this case is a square, whose formula is side square, times the height of the prism, and the height of this prism as a radical and simplest form was 2 square root 119. Now remember that this is not a third of a cube because this thing's taller than a cube. The base is a square, but that doesn't mean that it was the same height as it was wide. Okay? So we're going to have 20 squared is 400. 400 times 2 is 800. And then we're going to have 800 divided by 3. Square roots of 119. 800 divided by 3. And really, we should write it like this. 800, 20 squared is 400, times 2 is 800, square roots of 119 over 3. That's really the best way to write that answer. 800 divided by 3 is 266.6 repeating, so that would look like 266.6 repeating square root 19, but we really don't like repeating decimals, so this is a better way to write it than what I put in the teacher's edition. Okay? Any questions there? Volumes of prisms, surface areas, and volumes of prisms. Okay? We've got one more example. We have an equilateral triangular pyramid. An equilateral triangular pyramid. I'm going to work all of these examples, and I'm not going to do a lot of the practice because I would just be doing all your homework for you. So you can come back and watch the videos here to see how to do the homework because you need the experience of working these things out. And again, it's the same exact thing. So here we go on the page 297, all the pieces and parts of the equilateral triangular pyramid. Okay, angle 1. The base, remember, is an equilateral triangle. If it's equilateral, it's all the sides are equal, which means it's also equiangular. If it's equiangular, then each angle is 60. So angle 2 is 60 degrees. Each angle of that triangular base is 60. This would be a bisector of a vertex angle as we draw that altitude. So it would bisect the 60, making angle 130 degrees. This is a radius. A radius also bisects an interior angle, and so angle 3 is also 30 degrees. Angle 4. Angle 4 is hiding in this corner. If angle 3 was 30, and this is 90, then angle 4 is 60. So we've got some 30, 60, 90 triangles going on in there. We want the length of Q. This is the altitude. This is an isosceles triangle. So it bisects the vertex angle and bisects the base. It was equilateral, so the whole thing was 24. So those two pieces are 12. So Q is 12. A lot of geometry to know here. All right, so we know that Q is 12. We're looking for X. X is that little piece. We know that Q is 12. We know that 3 is 30, and this is 60. We've got a 30, 60, 90 triangle. We're looking for the short leg X. We know the long leg 12. So we're going to use our formula. Long leg is equal to short leg times the square root of 3. So long leg 12 equals short leg X times square root 3. Undo multiplication by division, so we divide square root 3. And so we get X is equal to 12 divided square root 3. We have to rationalize the denominator. So we get 12 square root 3 over 3. The 12 and 3 reduced to a 4, so you get 4 square root 3 for X. Well, what about Y? Well, since this is equilateral, then the altitudes intersect at a midpoint. So they're also the medians. The medians of a triangle are concurrent at a point, intersect at a point, such that little piece is half of big piece. Big piece is twice little piece. Y is twice X, 24 square root 3. The medians of a triangle intersect at a point that is 2/3 of the distance from a vertex to the midpoint of the opposite side. That's the official way to say it. What we get out of that is that when the medians intersect, it'll divide each median into two pieces such that the big piece is twice the little piece, or the little piece is half the big piece. Okay? Now, Y and Z are both radii of this regular polygon, you see. So whatever Y is, that's what Z is. So Z is also 24 square root 3. The height of the pyramid. We need to find the right triangle that it's in. Well, it's in a right triangle right there, and that's your 90 degree right there, because that height's got to be perpendicular to all the lines in the plane that pass through the point of intersection. We know what Z is, we know what H is, and we've got the 20. So we've got the 20, we've got the Z, whose value we know, and we're looking for height. So we're going to use C square equal A square plus B square. I'm going to come over here and clean up my workspace and do that. The hypotenuse is the 20, so 20 square equal my height square plus my other side, which is Z square, which is 24 square roots of 3 squared. So I'm going to do 20 squared is 400 is equal to height square plus, we're going to distribute that squared. 24 squared is 576. When you square the square root, it cancels and you get a 3. So we have a 576 times 3. 24 square root of 3 square is 576 times 3. 576 times 3. Or we could have put that in parentheses. We could have said, I lost it. Shouldn't have said that, but let me find it. 24 square root of 3 square. Let me show you how you could have done that. 24 square root 3 close square. I didn't close it. I need to close it again. Square. There we go. 1728. See? So we get, when we square that, 1,728. Need to pause and look. I made a little mistake back down the way, and I apologize. A while ago on this, we had a 12 square roots of 3 over 3, which should have been a 4 square root of 3, and somehow I grabbed the 12. So that should be a 4. Doubled is 8. Equal is 8. So that should have been a 4 square root 3 and an 8 square root 3 and an 8 square root 3. So over here in our solving, we should have had an 8 square root 3 square, which would have been a 64 times 3, which would be 180 plus 12 is a 192. That looks better. Sorry about that. And so we're going to subtract 192. And so we have 8 squared is equal to 208. And so we take the square root. To get the height, so we would take the 208 divided by 2 is 104. Let me back up somewhere where it's going to work for me. 208 divided by 2 is 104. Divided by 2 is 52. Divided by 2 is 27. Divided by 3 is 9. Divided by 3 is 3. That's messed up. Do it again. I'm having a little bit of trouble here. I apologize. It's getting late again, I guess. So 208 divide 2, 104 divide 2, 52 divide 2 is 26, not 27. Divide 2 is 13. We would write out the product of the primes, 2 times 2 times 2 times 2 times 13. Circle pairs for square root. From each set, you bring one out. What didn't get circled goes in. You multiply, and you get 4 square root 13 for the height. For square root 13. Okay? Now we need to find the slant height or the lateral height, L. So let's clear up our workspace. These are big problems here, or challenges you might want to call them. Don't call them a problem, it'll intimidate you. Okay, so now we want to find the slant height. So we need a triangle that it's in. That's a right angle. That's 20. We know that Q is 12. So we got 12 and 20 in lateral height in a right triangle. So we're going to do C squared equal A squared plus B squared. In this right triangle, The hypotenuse C is 20. So we'll have 20 square equal lateral height square plus Q, which is 12 square. We're going to do the exponents. We're going to have 400 is equal to L squared plus 144. We're going to undo to solve for L, so we subtract 144. We have L squared is equal to 256. We're going to get rid of the square with the square root, and we get L is equal to 16. So the slant height is 16. We've got all these pieces and parts, and so now we want to find the lateral area, total area, and volume. Lateral area. Now, the lateral area is 1/2 the perimeter of the bottom times the slant height, and the slant height was 20. The bottom is an equilateral triangle. It has 3 equal sides at 24 apiece. So we can say 1/2 of 24 is 12. 12 times 3 is 36. 36 times 20 is 720 for the lateral area. Whoops, the slant height wasn't the 20. I apologize. I'll do that again. I'm sorry. So lateral area is equal to 1/2 the perimeter of the bottom. The bottom is an equilateral triangle, so we have 3 sides each at 24, times the slant height. The slant height is L. I need to get where you can see the picture here. The slant height is this, not the edge. It's L. It's not that. The slant height is L, which came out to be 16. There we go. Okay, so we're going to try again. We'll just stick it in the calculator. 1/2 of 3 times 24 times 16. How's that? I'm getting brain tired. It's 3 minutes till 11. Almost hour from midnight. Anyway, 1/2 times 3 times 24 times 16. 0.5 times 3 times 24 times 16. I'm going to make sure those numbers are right. 1/2 3, 24, 16. 1/2 3, 24, 16. Good. Enter 576. And so the lateral area is 576. Okay? Total area. To get the total area, add the area of the bottom. The bottom is a triangle. Every triangle is 1/2 the base times the height. The base is 24. Now let's take a look at this. We're talking about the triangle. Base is 24. Height is that. The height is x plus y, which is 12 square root 3. We're talking about the area of the bottom. The bottom is a triangle. It's 1/2 its base 24 times its height, which is x plus y, which is 12 square root 3. So half of 24 is 12 times 12 is 144 square root 3. That's the area of the bottom, but we have to add the lateral area. So plus lateral area 576. So the total area is 576 plus 144 square root 3. We generally put the the part without the radical first as we write a complex number there. And then the volume is a third of what it would have been had it been a prism. So volume is 1/3. Had it been a prism, it would have been area of the bottom. The bottom's a triangle. Area of a triangle is 1/2 base times height again. Height being the 12 square root of 3, which was the x plus y. 1/3, excuse me, of the area of the bottom. And the bottom is a triangle, which is 1/2 base times height, times the height of the prism, which was the 4 square root 13. Let me rewrite it because it's not going to work over there. 1/3 times 1/2 times 24 times 12 square root 3 times 4 square root 13. Okay. 1/3 area of the bottom, which was 1/2 base times height, times height of pyramid. Let's see if we can put all this together. 1/3 times 1/2 is 1/6. 1/6 of 24 is 4. 4 times 12 is 48. 48 times 4. 192. You multiply the numbers, 192, and you multiply the names, and you get a new name, square root 39. So the volume is 192 square root 39. Any questions on the equilateral triangular pyramid? There's a lot of mathematics involved in these problems. And it's easy to mess up. I apologize when I make little mistakes. Don't be surprised if you make them. Just back up and fix them. That's all you can do. Okay? All right. I'm not going to do any of the daily work on this because you need the practice on that. So as you do those daily work problems, just go back and rerun these, the lesson part of the video. So this is going to be called lesson 11.3 and daily work 11.3, but there's not going to be any daily work recorded on the deal. So you're going to just have to know, hey, watch the examples over and over and over if you need to. All right.